Last class we started talking about law of exponents, and we talked about how with those law of exponents there are a total of 6 laws. We definitely learned 3 and we started learning the 4th one. This warm-up today covered the first 3 laws, so I want to review those first few laws just to make sure we're all on the same page. So last class the first law we talked about was if I have a to the first power, that's the same thing as a. So when a variable doesn't have an exponent, that exponent really is there, it's just an invisible one. So that's the first law that we learned. The second law we talked about was if I have a variable and I raise it to the 0 power. And if I'm a variable and I raise it to the 0 power, that equals the same thing as 1. Anything to the 0 power equals 1. So if I have a to the 0 power, it equals 1. If I have n to the 0 power, it equals 1. If I have 7 to the 0 power, that still equals 1. If I had a problem that looked like this, let me erase this so I can show you. If I had a problem that said 7a to the 0, right now in this problem, what's being raised to the 0 power? Well, just a is. So I would only circle a, and I know that equals 1, so I'm going to cross it out and put 1. So what operations between 7 and 1? Multiplication, so 7 times 1 equals 7. Notice 7's exponent is not 0, 7's exponent is invisible, and it's actually a 1. So just kind of keep that in mind as we're progressing through this. All right. And then the last law we learned was when we had a negative exponent. If I have x to the negative second exponent, what does a negative exponent do? Well, a negative exponent turns a problem into a fraction. So every time I have a negative exponent, I circle it. I turn this into a fraction by putting it under 1, and then I move this down. I'm going to take x to the negative second power, I'm going to put it on the bottom, and it's going to turn to x to the positive second power. And notice nothing is left on the top, so nothing left on the top, I'm going to put a 1 there, and this would be my answer. So just kind of keep that in mind as we were progressing through this warm-up. So let me see if I can erase some of that. Hold on a second. Alright, so I don't know why that's not going to erase. Let's see. Technology at its finest, not agreeing with me. That's not going to erase. Alright, so we're going to do the best we can. Alright, so number 1 is the number 1 most missed problem in this unit, because you see 2 to the 4th power, and you immediately tell me it's 16. But you'd probably tell me it was negative 16. If you have negative 16 written on your paper, you are 100% wrong, because a negative exponent does not make a problem negative. What does a negative exponent do? It turns something into a fraction. So I'm going to turn this into a fraction by putting it over 1. I'm going to circle my negative exponent, and what do I do with it? Bring it down. And when I bring it down, 2 to the negative 4th turns into 2 to the positive 4th. And 2 to the positive 4th is on the bottom. Notice nothing's left on the top. I'm going to put a 1 there. If I circle this, I'm losing a point. Why am I going to lose a point? Because I can still clean up 2 to the 4th power. 2 to the 4th power equals 16, and I have a 1 on the top, and this is my answer. Notice originally we said 2 to the negative 4th was negative 16. Negative 16 and 1 over 16 obviously do not mean the same thing, so be very careful. And another friendly piece of information, if you type 2 to the negative 4th power in your calculator, what do you get? Everybody take a moment and type in 2 to the negative 4th power. You should get 0.0625, which I don't like decimals, so if you hit math, enter, enter, what do you get? 1 over 16, which is exactly what we got right there. All right? So let's now look at number 2. Number 2, what do you notice that's alarming about this problem? Well, I notice a negative exponent, so I'm going to circle it. What do negative exponents do? They turn something into a fraction. So I'm going to put this over 1. So out of 4 and x, which one's moving to the bottom? Well, 4 is, because x doesn't have a negative exponent. X's exponent is 1. So x stays on the top. 4 to the negative second power turns into 4 to the positive second power. And if I circle this, I'm losing a point, because I can clean up 4 to the second power and make x over 16. If we look at the next one, 5x to the negative 6th power. What's the first thing you notice in this problem? I have a negative exponent. What do negative exponents do? They turn the problem into a fraction. So put this problem over 1. What am I moving to the bottom? X. Am I moving 5 to the bottom? No. Why not? It doesn't have a negative exponent. So 5 stays on the top, and then x to the 6 goes on the bottom, and I'm done. I know I'm done because I have no negative exponents in this problem, and every variable I only see x once. If I had an x on the top and an x on the bottom, I know I'm not done. Just kind of as a friendly piece of advice. Alright, so because number 2 and number 3 are very similar to number 4, I'm going to skip number 4. If anybody needs me to go over number 4, make sure you check with your partner, because since I'm not there, it's going to make it a little more complicated. But I do want to look at number 5. Number 5, what's something alarming you notice? Negative exponent. But notice my negative exponent's on the bottom, so where's it really going? It's now going on the top. So now I have 3 to the positive 2nd power. Who's left on the bottom? 1. So clean this up. 3 squared is 9. 9 over 1. If you circle this, you're losing a point because my directions say simplify, and this is not simplified enough. So 9 over 1 equals 9, and I'm done. Let's look at number 6. This is my favorite type of problem because whenever anything is to the 0 power, it always equals 1. So, done. Awesome. Let's look at number 7. What's the first thing I notice in this problem? The first thing I notice is a 0 exponent because 0 exponents are my favorite because 0 exponents turn that whole piece, oops, and I'm scribbling out too much, turn that whole piece into 1. And 1 times anything is just itself, so really this whole piece is gone. What's the next alarming thing you notice about this problem? I have a negative exponent. What do negative exponents do? Well, they turn my problem into a fraction. So which one of these bases am I moving? X. So 12z cubed y cubed on the top and x to the 5th on the bottom. I know I'm done because I have no negative exponents and every variable is only seen one time. 1x, 1z, 1y. Let's go ahead and look at number 8. What's the first thing you notice about number 8? I have a 0 exponent. Anything the 0 exponent equals? 1. What's the next thing you notice in this problem? I have a negative exponent. That negative exponent turns my problem into a fraction. I'm going to bring it down. So I have 8y cubed over x to the 7th power. Let's look at number 9. What's the first thing you notice about number 9? Well, I have negative exponent y and a negative exponent m. So y is being shifted down and m is being shifted up. So I'm going to have 2xz m squared all over 8ky cubed. If I circle this, I'm losing a point. Think about it for a second. Why do you think I'm losing a point on this problem? Because of my numbers. Look, 2 over 8. In my calculator, can you type 2 over 8? 2 over 8. You get 0.25. Gross. Decimal. Make it a fraction. Math. Enter. Enter. 2 over 8 simplifies to 1 over 4. So I can rewrite this and say 1 over 4 and then zm squared ky cubed. And this is my answer in that beautiful yellow color. Now technically this 1 right here, I don't really need. I can erase it if I wanted to, or you can leave that 1. I'll be okay if you leave that 1 on that problem. All right. So whenever you have numbers, you always want to make sure you can simplify them. If you can't simplify them, no big deal, you leave them. If you can simplify them, you always want to be able to. Because again, my directions say simplify. So 10, 11, and 12, I want you to check your answers with your partner. If there are any disputes, make sure you go over those problems as a class. Otherwise, we will keep going.